Jai Hind, welcome to the course Network Analysis and Synthesis. And today I am going to discuss when the two-port networks are terminated by. So what will be the input impedance, what will be the output impedance, what will be the voltage gain in case when the ports are terminated. So suppose this is your two-port network. This is V2, this is your I2, this is your V1, and this is your I1. This is your two-port networks. Two-port networks. So I am going to discuss when two-port networks are two-port network is terminated. Okay. So what does it mean? It means suppose this is your network. Okay. And this is your input port. So input port, suppose having some voltage source, this is your I1, this is your I1, and this is the supply voltage source with some series resistance Rs. This is your two-port network. And the output port is terminated by some load. Say this is your ZL. You can say this is your ZL. You can say that this is your ZL. And this is your voltage, and this is your current, plus and minus. So this is the case when the two-port networks are terminated. Means input port has some voltage supply Vs with series resistance Rs, and load port is also, or output port is also terminated by load ZL. So what you have to do, you have to find first input impedance, which is we can say the Zi. So Zi in case of V1 and I1, output impedance, say this is your Zi, this is your Z0. So Z0 is basically, you can say V2 upon I2, and third, voltage gain, at least voltage gain. So voltage gain, that is equal to V2 upon Vs, or in some case V2 upon V1. This voltage, this is your V1, this voltage your V1, input port voltage, and this is the supply Vs. So these parameters we have to calculate when the two-port networks are terminated. So how we will do it? What are the procedures? So what you have to do, you have to draw and we have to find these parameters in terms of two-port network parameters. And what are the two-port network parameters? Two-port network parameters are the Z parameters, which is known as open circuit impedance parameter, Y parameters, short circuit admittance parameters, ABCD parameters, that is transmission line parameters, and H parameters, hybrid parameters. So you have to find or these parameters in terms of Z, Y, A, B, C, D and H. So how will do it? So for that you have to draw the equivalent circuit of Z parameters. How will do it? So basically we know that suppose this is your two-port network. This is your, if you remember, this is your V1, this is your I1, and this is your V2, and this is your I2. So for Z parameters, how will get Z parameters? When the V1 and V2 are the dependent and I1 and I2 are the independent. Means when the V1 and V2 are the function of I1 and I2, we get the Z parameters. So we can write V1 is equal to Z11 I1 plus Z12 I2, and V2 is Z21 I1 plus Z22 I2, right. So these are the equations in terms of Z parameters. So just from these equations we can draw the equivalent equivalent network of Z parameters. So how we'll do it? So let's see. So this is like this. So this is your V1. So this is your voltage, and this is Z12 and I2. So it is a voltage source. So it is a voltage source. Which type of voltage source? It is a dependent voltage source. Then just we need some space, so just we can write here, or we can write some, so that we can draw these circuits. So this is so we can write here V1 is equal to Z11 I1 plus Z12 I2, and V2 is Z21 I1 plus Z22. So from these equations we can draw the equivalent network. So this is your V2, this is your I2, this is plus, minus, this is your Z22, this is Z21 I1, this is your Z12 I2, this is your I1, and this is your V1. This is Z1. Okay. So this is the, what is this? This is the equivalent network of Z parameters. So we can just, if you apply Kirchhoff's voltage law in this loop, so V1 minus I1 Z11 minus Z12 I2 is equal to 0. So V1 is equal to Z11 I1 plus Z12 I2. So this is the current control voltage source. This is also a current control voltage source. So this, if we write the KVL here and here, we get these two equations. So verify. Now this network is terminated. Suppose this is terminated by this load. This is your ZL. This is terminated by ZL. And suppose you want to find the ZI1 when the load is terminated, and this is ZI1, and ZI1 is V1 upon I1. So from this circuit you have to find ratio of current to voltage, that is V1 upon I1 at the input terminal when the output is terminated by ZL. So how will I start? Just write the basic equation for Z parameters. So Z11 I1 plus Z12 I2, and V2 is Z21 I1 plus Z22 I2. We can write this is the Z parameters. And in addition, V2 is, so V2 is voltage across this ZL, and V2 is also minus I2 into ZL. Clear? So what you have to do, we have to just put this V2 is equal to minus I2 ZL and solve for this. So just we are going for another page. So it is, so we can write, or minus I2 ZL is equal to Z21 I1 plus Z22 I2, and V1 is, Z11 I1 plus Z12 I2. So what we have to find? We have to find V1 upon I1. So V1 upon I1, so what we will do, just replace I2 from here and put here and solve for the V1 upon I1, we can get this. So V1 upon I1 we can write, or V1 upon I1 is, we can write Z11 plus Z12 Z21 upon, suppose we can write Z21 upon minus Z22 minus ZL minus I1, so, or V1 upon I1. So this is something, this is your V1. So upon line V1 is Z11 plus, this is your Z11 and I1. This is you can write here Z11 I1 one lines, okay, and Z12 I2. So I2 is, I2 from where we can get this. So I2 is this one. So V1 upon I1. So V1 upon I1 is equal to Z11 plus Z12 Z21 upon minus Z22 plus ZL. So it is Z11 minus Z12 Z21 upon Z22 plus ZL. So or V1 upon I1 is equal to Z11 Z22 plus Z11 ZL minus Z12 Z21 upon Z22 plus ZL. So what is this? So this is the, we can write in Z11 Z22 minus Z12 Z21 plus Z11 ZL divided by Z22 plus ZL plus ZL. So if we write them in the matrix form for the Z parameters, so this is your Z11, Z12, Z21, Z22, I1, I2. So determinant. So delta Z is Z1, Z22 minus Z12, Z21. So we can replace this. This we can replace by this. So it can be written as V1 upon I1 is equal to delta Z plus Z11 ZL upon Z22 plus ZL. So this is V1 upon I1 is nothing but it is Zi. So Zi is input impedance when load port is terminated by impedance ZL is Zi1, which is V1 upon I1 is delta Z plus delta Z11 ZL upon Z22 plus ZL. So this is your input impedance. This is your input impedance. So Zi, or you can say this is Zi. This is, I think we have taken in place of the Zi. So Zi is of your delta Z plus Z11 ZL upon Z22 plus ZL. So this is the input impedance when load is terminated by impedance ZL. Now second, output impedance. Output impedance, that is your Z0. So the circuit is like this. This is your two-port network. This is your, this input is having source impedance RS. Say this is your RS. This is your I1 and this is your V1. And this is your V2. This is your V2 and this is your I2. Plus minus. So Z0 is V2 upon I2. So Z0 is V2 upon I2. So from the using the equations or relationship between the Z parameters variable, we have to find V2 upon I2 when input port is terminated by source resistance Rs. So how will do it? Just start basic equations. V1 is equal to Z11 I1 plus Z12 I2 and V2 is Z21 I1 plus Z22 I2. Okay. So, and in the last equation we had written V2 is equal to minus I2 ZL. Here V1 is the voltage across Rs, which is, and V1 is minus I1 Rs, because the current through this will be, Rs will be just opposite to I1. So you can write up minus I1 Rs is equal to Z11 I1 plus Z12 I2, and V2 is Z21 I1 plus Z22 I2. Now you have to find the ratio of V2 to I2. So what you have to do? You have to replace this I1. So I1 is, it is coming, if we simplify, I am writing directly, we can check. It is coming minus Z11 plus Rs into I2. So we put this expression of I1 in place of I1, we put this value and go for the V2 upon I2, we get Z0. So we get Z0 is V2 upon I2, which is coming, it is coming like this, delta Z, which is the determinants of Z parameter, plus Rs Z22 upon Z11 plus Rs. So this is in output impedance when the input port is terminated by source impedance Rs. So we get this is the output impedance. Now we can solve for the Vs. So Vs is we can go for the voltage gain. So voltage gain Vs minus, so if you Vs minus Rs I1 minus Z11 I1 minus Z12 I2 equal to 0. How will get this? So this is like this. This is circuit like this. This is your Vs. This is your Vs. Input port. This is your Is. Okay. This is your V1. Okay. This is your Z11. If you remember, like this, it is like this. It is like this. This is plus minus Z1 to I2. This is your Z11. Okay. And then this is your suppose this load port is, this is your complete. This is your Z22. This is your I2. This is your V2. This is your ZL. This is Z21 I1. Okay. So from this, if you apply Kirchhoff's voltage law, so this is your plus minus. So minus to plus Vs minus, this is your Rs. This is your I1. The minus I1 Rs, then minus Z1 minus Z equal to 0. So Vs is equal to, we can write and put and V2 is minus ZL I2, this one, this V2. If the current through this is, so I2 is just opposite to current through the ZL. So just and minus I2 ZL minus Z22 I2 minus Z21 I1 equal to 0. So from these two equations we can get Vs of V2 upon Vs. We can find on simplification we can find V2 upon Vs. V2 upon Vs. So it is coming, I am writing, you can check it, it is coming minus I2 ZL upon RS plus Z11 Z22 plus ZL minus Z12 Z21. So this is the voltage gain. So this is the output voltage when the load is terminated by ZL, and this is the Vs when the input port is having some supply with some input resistance Rs. So this way we can find parameters of when the two-port networks are terminated by load by any parameters, either Z we can go for the Y, H, any parameters we can use. What you have to do, you have to draw the equivalent circuit of that parameters and go for the Kirchhoff's voltage law and current law, and just apply basic equations to get the input impedance, output impedance and voltage gain. So in the another lecture we will carry out some other parameters when the two-port networks are terminated. We carry out the analysis taking the some other parameters, Y parameters or H parameters. So just we are stopping here. Thank you very much. Jai Hind.